I believe we can start right now. So please welcome on the stage Martin Havelka.
Thank you. My name is Martin Havelka, and I work at Outreach. I'm a software engineer at Outreach, and today I would like to speak about microservices, what I find out to be the caveats, what I find out to be good about them. I think the previous speaker gave me a good ground and base, and I completely support his claims that you should really use them only when you have a really good reason for that. So I'm not going to anyhow contradict that. So first, I would like to a little bit compare the monolith and microservice, explain what is it, because maybe somebody doesn't know. Then I will try to describe what I think it's good about the microservices, what's bad about the microservices, talk about the best practices, and then I would like to talk about some pattern, one of the patterns that are used during the microservice implementation. Okay, so as I said, I hope everybody knows what is it about, but just to cover it up, the monolithic architecture is the architecture where you have everything in one place. Even like long time ago, maybe still somewhere happening, even the UI was the part of the one big application that was generated and shown. Then in the browser nowadays, usually you have the front end and back end at least separated, but not necessarily. And you had like one database where you are putting all the things. This is still a good architecture, definitely very useful. But if you want to, if you scale up and you have like a huge project or a huge product, probably you will start to have issues with scaling and other things. So you will start to look for a solution, and definitely you will hear about microservices. The microservices is nothing else than just splitting the business logic of your project into some smaller areas, into smaller logic units, which will take the part of that business logic and try to encapsulate it and isolate it. Okay. So let's start what's good about the microservices. What I find really important, it's the independent deployment. Basically, what does it mean is that you don't need to deploy the whole monolithic architecture at once, so you are able to do CI/CD, continuous deployment with less impact on customer. So you can really just deploy the specific part of the architecture, and since it should be completely decoupled, then it should not affect the remaining functionalities, remaining features, remaining areas of your app. The next point is scalability and resource management. As I said before, the scalability is very something with monolithic architecture hardly done. Maybe the speaker that is sick today would tell us how to overcome that, but unfortunately he is not here. But in the microservice architecture, you are very able to specifically increase the resources or scale the specific part of the application that you need to, and save the resources on the parts that doesn't require that. Modular design, it was also mentioned here that you are able to encapsulate the functionalities, the business logic, and you can basically make it loosely coupled, so you are able to put it into different services. No single point of failure. This is the point where you should have the microservices loosely coupled. Therefore, if one of the service fails, the remaining of the system still keeps working, and you don't have to troubleshoot all your customers at once, but only maybe some of them that are affected. The other good point is that you have smaller code base, which doesn't necessarily mean you have the smaller code base in total, but the each service it's covering it's only a smaller part of the overall code base. And if you have some bigger application, like for example at Outreach we have, usually you have like a whole team that is taking care about several services or even just one service, and it's much more convenient for them to really be focused on the part of the code base that they are maintaining, rather than to be, you know, having the whole stuff at the plate. Okay, so let's now switch to the worst part of the microservices, and it was already mentioned here before. It is the complexity. It's definitely more complex than to have the monolithic architecture, and it brings a lot of issues and a lot of troubles that you need to think about, that you need to solve, and when you will be deciding to switch to microservices, definitely consider this. The next point is data consistency. This is my favorite topic because as a software architect and developer, I'm on daily basis encountering this, and the data consistency issue. I would like to talk about this a little bit later, so I will skip it for now. The next point is network latency, which brings up an issue of how fast the microservices will work in total. Because if you have monolithic architecture, you basically the components can communicate in no time or very low latency. But if you have microservices all around the world, or maybe they are in the same data center, but even then they are slower in communication than if you have a monolithic architecture. The operational overhead, it's the one that I'm luckily not that much worried about usually, because some other team take cares about this one. But it's the what was already mentioned here in the previous presentation, the team that is taking care that everything is well deployed, everything is working, like from the perspective of the architecture and not the architecture but infrastructure. And this is again costs that needs to be considered. I think the very similar is the deployment challenges, which basically means you need to really have, like already mentioned, Kubernetes or some other orchestration that will make your life easier. Otherwise, you will get lost and you will not be able to really effectively use the architecture. So about the best practices, one of the most challenging and difficult parts that I find about the architecture, it's monitoring and logging, because suddenly you have the logs spread it all around, and you are not able to really effectively debug the whole trace, how some request, for example, was processed. And this can get very challenging unless you have in place some good measures, like for example, you have at least some trace ID that will track the request through all the services that it went through. Currently, we are using Datadog for this, and I have to say, even though the tool is very expensive, it's it's state of the art, at least to my knowledge, and we are able to very effectively, let's say, debug the issues. If you don't do this, I think you will be in big troubles, because you will not be able to find out what happened, and you will spend nights and days just to trying to figure out what really happened. Then, as I said before, you need to have CDCI in place, or you don't need to, but without that, it would be painful to really gradually roll out new features and do some deployment. And I would really recommend to read Reactive Manifesto. On the end of the presentation, in the resources, you will find a link to that. And there are some good principles that I think you should implement. Oh, uh, some of them, one of them is responsiveness. It means the microservice should respond in some reasonable time, not take too much time, be quick in response if possible. So the whole system, it's, let's say, usable. It should be resilient. It's basically a high availability. So each service, again, should be able to recover, should be able to start when it stopped before, if it, for example, if it for some reason fails. It should be elastic. This is the scalability. So when you need to be able to increase the workload on some specific service because, I don't know, some peak in a traffic came and it's you should be able to cover that. And this is maybe opinionated, but it should be message driven rather than to use some REST APIs or to use other kind of direct communication. So you don't do the tight coupling of your microservices. Now I would like to go a little bit deeper into one of the patterns that is used when communicating between the microservices. It's called Saga pattern. Basically, the prerequisition for this pattern is that the services involved are using some database or some other storage to persist some kind of information. The business transaction involves multiple services that are having the database or other persistent storage, and that you are not able locally in one of these services to do the whole transaction at once. The pattern coordination is possible to do by two methods. One is called choreography, and the second one is called orchestration. Basically, the choreography approach is when each service is very independent and just after it successfully do its part, it emits a message, and the message is then consumed by other service or services, and they do their part. And again, they can emit another message, which would trigger the chain of let's say those local transactions. And on the end, if everything is successful, the success message is emitted, so the whole transaction is basically closed, and we consider it a success. If one of the local transaction fails and the service emits a failure message, the whole system needs to be able to revert, or let's say compensate for this and take an action. This is the difficult part of this pattern because you need to have those revertible transactions, and each local service needs to kind of know what to do. Okay. Some drawbacks about this pattern is again the complexity, because as I said before, you need to write down the revert actions, and also anything that includes microservices is usually complex. You have only eventual consistency there, because when you already do the local transaction, you are basically already in state that it's ready to be used, and you eventually the whole process will succeed or roll out. But in the meantime, for this local information in one service, it's considered to be done. So only eventually consistency is there. And it's, of course, increased network traffic. There are some more drawbacks, but I didn't want to put too much, so it's not kind of throw you back. Okay. When I am designing some software or trying to envision how something will look like, I sometimes really like to do some kind of emulation or simulation how it will work. Actually, even with the microservices, I time to time do like, let's say, try to write down a quick model and try to envision how the messages between the microservices will travel. And I usually write for that like little script that would give me an idea, and then I am able to play with that and let's say really just and really just like it's just like like mental help. And I for you I prepared like the kind of sketchy way how I'm doing this, so maybe you can get an inspiration out of that, maybe not, maybe you will find it silly. This is this is like a little snippet of the Go code which wrote for this event, which consists of three independent services. One is the order service, the inventory service, and the payment service. And here I am creating channels, which is basically some kind of like simulation of the communication between the independently running Go routines. You can envision it as a Kafka or maybe some other messaging system of your choice. Then I have here the Go services. So basically, at this time, I am spinning up three independent processes, which, as you can see, for example, in this one, now just waiting for the message to come. So from this moment on, I have there three services that are completely independent. They are running as separate Go routine processes, and I'm here sending the first message, which would be the initial message that, for example, comes from an API to create an order. And then I'm just leaving this up to the each service to process it and do its job. And I'm listening only for the final message to come, so I can evaluate what happens if it was success or failure, and if I need to do some kind of rollback or recovery, as I said before. We can even try to run it just to see what will be the result. As you can see, uh, in this case, we had great success and everything went well. So we created the new order. Then the inventory service received that the order was requested and checked the stock. The payment service received that the stock was checked and it's available. And as the last, we tried the payment, which went successful, so everything went well. Uh, Now I will increase the entropy in the whole system. So it's only 50-50 that each of the service will not fail. Okay, it succeeded again. Let's try it again. Okay. And in this case, we see that the new order was created, but we don't have the stock available. And we have an error, so we have to roll back again all the previous transactions. I find this useful. It's up to you. Maybe not, but it's nice that you can envision how it can work. Okay, I make it much more shorter than the previous speaker. So thank you, and if you have some questions, please ask. Mhm. Can you please elaborate more about resource management as a benefit of microservices? It wasn't clear since as an organization, more services you have, more different resources you need to provision and maintain. Uh, that's true, but you are able to more focus the resources where they are needed. Because you are able to scale each service at will, and therefore you are able to, as I said, focus the resources. That's what I meant. Are you able to test multi-service operations locally? Definitely. You are able to test multi-service operations locally. We have for this local devenv, which allows you to run multiple services in multiple pods, and you are able to do end-to-end tests, basically. And yeah, it have a lot of. It's not easy to do that, I would say. Like we have the whole team. It's just preparing for us this dev environment, so we as developers are able to do our jobs, but it's possible. How do you test these complex scenarios where multiple services communicate together on CI? We are having also we are using the feature flags as was mentioned before, so we are able at will enable and disable some of the features on each service. And also we are having, I think it's very standard to have some kind of staging environments or other environments where you are able to test this. I'm glad that I don't have to use it anymore, but now I'm really like into the Golang, and I would like to explore Rust. So probably already kind of understand what is my brain wiring.
All right, do we have any questions from the audience? Oh, there is a question from Slido.
We have both. We have continuous integration and also continuous delivery. um, yeah, we have both. What branch model do you use? We are using the branch model mentioned before, so we have only simple feature branches doing pull requests, and then we are merging directly to main with all the CDCI involved, all the checks of the linters and everything goes through, the builds are done and everything. What we actually did quite like few months ago, like maybe half a year ago, we were still using a developer branch because when I started to work at Outreach, it was very tough. Main and master on some other ones. And actually, it was kind of shooting into the dark. I was not exactly sure what I'm doing all the time, so it was safer to have some branch to save our ass, at least for a while. But now, when we are a little bit more sure what we are doing, actually, we switch to the full CD. Main or master? Oh, that's a good question. Maybe we can do a vote. Who think main is better? Okay, and who prefer master? And who prefer none of those? We deploy to stage and then we deploy to production, or we have different rings, how we call it, orange, white, and green rings, dependent on what kind of, what let's say, level of customer it is. The last question I will not answer because I think I don't want to get into that one.
That could be probably the topic for the next meetup. Do we have any questions from the audience? If not, thank you so much, Martine, for your presentation. Thank you for your questions.